Hello, I'm Niall, and today we're going to be exploring the Stanford Quadruped, what it is, and how it works. Let's dive right in. Well, what is the Stanford Quadruped? It is an open source quadruped built by a few students from Stanford University. I was looking to build a unique and interesting robot. I had already built a few robots with wheels, and wanted something more exciting. Quadrupeds are definitely exciting. They are built all over the world today, and have a lot of potential growth for the future. This robot is made up of more than 50 different parts, and can be built with anyone with intermediate robotic skills. What are the main parts of the robot? There are 6 main parts of the robot. The first main part is a carbon fiber. There are 4 different pieces of carbon fiber, the top and bottom, and the leg and the knee flex. The top and bottom help keep everything compact. The leg and knee flex are the legs and help the robot move. The next main part is the 3D printed parts. The 3D printed parts serve as the hip and connect the robot in the sides and in the middle. The next main part is the servos. There are 12 servos on this robot, 3 for each leg. One of the servos helps rotate the hip, while the other 2 move the leg forward and backward. The next main part is the PS4 controller. The PS4 controller gives inputs to the robot, and asks the servos to move in certain directions. The next main part is the battery. This is a 2C 7.4 volt battery. It powers the robot and the Raspberry Pi using a 5 volt power regulator. The next main part is the Raspberry Pi. The Raspberry Pi is the brain of the robot. It is a microcontroller. It has its own operating system, which is Raspbian. It holds the code for the robot and joystick services. Let's dive into the code. In the robot service, we define a function that creates a configuration and receives inputs from the joystick service. In the joystick interface, we map the controls for the PS4 controller and send the inputs from the PS4 controller to the robot service. In the calibration code, we define the default position for the legs of the robot using a numpy array. Let's see the robot in action. How does the robot work? First, the battery gives power to the servos and the Raspberry Pi using a 5 volt power regulator. Then, the PS4 controller connects to the Raspberry Pi via Bluetooth. After that, when movement is sensed on the PS4 controller, it is sent to the joystick service. The joystick service interprets the movement and sends it to the robot service. The robot service uses these inputs and controls the servos accordingly. This is a diagram that shows which buttons do what on the PS4 controller. The buttons on the left-hand side move the robot up and down and rotate the hips from side to side. The button in the top left arms and disarms the robot. The left joystick moves the robot forward, backward, left, and right. The PS and Share button pair the controller with the robot. The button on the top right puts the robot in trap mode. The X or Cross button switches the robot between 3 different levels of elevation. The right joystick rotates the robot when it is idle and turns it when it is trotting. That is how the robot works. Thank you for watching. I hope you guys enjoyed it. I would love to know which robots you are building in the comments below.